Hey guys, what's up everybody? Welcome or welcome back again to another banger, exciting video from the Apex Academy of Mathematics. We're learning the language of the universe begins here, and we're going to be talking about solving simultaneous equation, but of course we're going to be talking about using the substitution method. Alright, so my name is Akin, otherwise known as Apex Selenium, and if this is the first time here on my channel or you've watched previous videos before and you've enjoyed the content, please consider dropping a like on this video and previous videos, smashing the subscribe button, pardon me, and turning on your post notification bell so you can be notified when I post another video. All right, now as I said to you before, or as you can see the title, that we're going to be solving simultaneous equation using the elimination method, so please make sure that you watch this video to its entirety for full value and full satisfaction. I also want to make a note and use the opportunity to tell you that I want to do a little bit more for my subscribers and for my students. So of course, if you are doing any form of math courses, whether it be university, college, high school, make sure that you want to tune into my live, which will be starting in the next couple of weeks, because in the time of recording this video, we are indeed in a pandemic crisis where no one is allowed to go into the schools to do physical classes, so mostly online. So a lot of students do need that extra assistance and that extra teaching. So please, of course, if you're watching this video and you know someone out there who needs the assistance, please consider sharing this video and of course having them subscribe to the channel so they're able to join the live sessions when I'm teaching this and many other topics to come. All right, so without further ado and rambling, let's jump right into today's video, which of course, as I mentioned to you before, is solving simultaneous equation using the substitution method. I do want to make a note also that this is a video request by Carisi Seymour on my channel, so thank you so much. This is for you and many other students who are struggling, so let's get into it. In my previous videos, I've also explained to you all the steps of simultaneous equation using the elimination method, and I've also did another video where we're going to be talking about 3 examples and working them out, so you want to take a look at those. But for this one, this is a same simultaneous equation. Oh my gosh. And of course, this is another method that you want to make use of. All right, so let's jump into it. So using the substitution method. All right, so the substitution is a method by which a third equation is created, all right, by making a variable with the coefficient of 1 becoming the subject of the equation. All right, let's just read through this first and let's make sense of it. All right, so although it is very much applicable when the coefficient is greater than 1, it is more effective when it's exactly 1. All right, let's make sense of this first example here. Let's go over to an example here. All right, we're not going to work out the question, but we're going to look at what it is saying. Now, this here is a typical simultaneous equation. As you can see, 3x minus 4y is equal to 17, x minus 4y is equal to 3. All right, and we're going to apply the same steps, name your equations, yada 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 yada, you know the whole works. However, to do this question, there are some times when the substitution method is the best method to use. All right, in this example, both the substitution method and the elimination method is applicable. All right, but there are going to be questions, of course, those videos will be made where we're talking about quadratic simultaneous equations. There are situations where the elimination method is not applicable. It cannot be applied. So that now forces you now to have to learn what the substitution method is. Do look out for that video when it is made, and to know that, you're definitely gonna have to, of course, subscribe to the channel to know that. Okay, so those are called quadratic simultaneous equations, or quadratic equations using simultaneous method. Okay, so here's where you can recognize easily when the substitution method is best applicable. You recognize that it is best applicable when you have a variable in the equation that doesn't have a number in front of it. Here, All right, now, not that it doesn't have a number, the number that is in front of it is understood, and that number is 1. Now, that's the best time to use the substitution method. As I said to you before, not that it's not applicable. If there was a number here, let's say 6, it's still applicable. But using the substitution method, when all the coefficients are greater than 1, it's far, far more complicated than using the elimination method. So it really comes down to which method is best and why. So here, in this video, of course, we're talking about the substitution method. And of course, this question, if you want to apply that method, this is the best time to do so. Why? Why is this the best time to do so? Because the number in front of the x here is 1. And that pretty much is what I was trying to say when I was explaining this section here. The substitution method is the best method with a third equation is created, all right, in making the variable of coefficient of 1 become the subject of the equation. We haven't done this part as yet, but here is how we're going to do it. So the first thing you want to do here is to identify which of the equation has the coefficient of 1. It is equation 2. So let's go ahead by naming our equations. Okay, let's name our equations first of all. So of course we're going to call this here equation 1 and call this here equation 2. After you've named the equations equation 1 and equation 2, you recognize clearly that it is equation 2 that has the variable with a coefficient of 1. So we're going to make x the subject of the formula. I'm going to be dropping videos on my channel about transposition of the formula, so do look out for that, or you can check the playlist in the description or at the end of my video to see if you can find the algebra playlist with transposition of the formula. All right, so for now, let's jump into it. We're going to make x the subject of the formula. All right, so to make x the subject of the formula, we pretty much need to remove any variable or any term that is beside our x, and in this case we have a negative 4y, so we're going to be adding 4y to both sides, or better yet, we're going to bring the 4y, the negative 4y, over to that side, on that side over there. Okay, so we're going to say using equation 2, x is equal to 3. Since the negative 4y goes over to the other side, it becomes 4y, positive 4y. And this is our third equation that I was referring to. All right. So the substitution method is the method by which a third equation is created. All right. And there, to create the third equation, you simply have to make the variable with the letter make the variable with the coefficient of 1 become the subject of that equation. All right, so without further ado, let's jump into, of course, the previous steps, the next step that we have to consider. Now it says, whilst the elimination process is applicable when there's two linear equations, as I mentioned to you before, a regular simultaneous equation, the substitution method is applicable when there is two linear equations also, and also one linear and one non-linear. A non-linear equation is basically called a quadratic equation. So when a linear and a non-linear equation comes together, we call it a quadratic simultaneous equation. Do look out for videos on that very, very soon. All right, so now that we have done that, let's jump into the actual steps. Of course, we've completed step 1 very easily, name our equations. Step 2, we have located the equation with the variable that has the coefficient of 1. In this case, we know that it's equation 2, and then hence we're going to make this variable the subject of the equation, which we have already done. That's what's going to create the third equation. So we've done step 1 and step 2 already, and see, the question is just at the beginning stage. All right, lovely. Let's look at step 3. Step 3 says here that we're going to be substituting the expression that was created by the third equation, right? All right, so substitute the expression created in the subsequent equation for the subject of the third equation. So the subject of the third equation was x. That's the subject of that equation. It creates an expression here. That's the expression 3 plus 4y. The subsequent equation is equation 1. Reason being, I used equation 2 to create equation 3. So it would make much sense to take equation 3 to put it back into equation 1. what will happen if you made that error? If I take equation 3 and put it back into equation 1, look at what will happen. Let's look at it. So here's x, we're going to put 3 plus 4y, and we're going to minus 4y, and that's going to be equal to 3. It just shows you here that 4y cancels 4y, so 3 is equal to 3. It shows you that once this happens, and you made that error, and you're realizing that you're still not having an expression to simplify or to solve, this is simply telling you that the equation that you have substituted the expression in was the equation you used to create the third one, or the third equation. I hope that rambling there was not confusing you, but the point is, if you use equation 2 to create equation 3, you cannot substitute equation 3 back into equation 2. That will cancel out everything. So you need to substitute it into equation 1. Now, vice versa. If it is that you used equation 1 to create equation 3, you need to substitute the equation or the expression you've created back into equation 2. So hopefully you got that understanding. That's the point I'm saying. Whatever equation you use to create the third equation, you cannot resubstitute it back into it. You have to choose another equation. All right, so hopefully that is a little bit clearer for you. So what equation did we use to create equation 3? We used equation 2. So we're going to take this expression and put it into equation 1 for x. So anywhere I see x, I'm going to put 3 plus 4y. I'm going to take this expression here. Okay, I'm going to take this expression here and put it anywhere I see x, right here, right there. Okay, all right, so let's get to that work. Let's get to work. So we have, let's zoom it up here. We have 3x, oops, not 3x, but x is 3 plus 4y. So we have 3 times 3 plus 4y, and that's going to be minus 4y here, minus 4y, and that's equal to 17. All right, lovely. So that's what we have done so far. Okay, let's go over here and see what this step says here. So substitute the expression created in yada yada yada, this whole bunch of writing, and then we're going to solve for that variable. So let's see what happens here. So we're going to be solving for y. Distributive law. 3 times 3, 9. 3 times 4y, 12y, minus 4y, and that's going to be equal to 17. So we're pretty much going to be solving the equation for y. So we can leave these two y's on this side because those are the ones that we want, but we can simplify them now. That 12y minus 4y, let's write it first. We have 12y minus 4y is equal to 17. I have a positive 9 over here, so I can subtract 9 from both sides. So I have a minus 9 over there. It goes over and becomes negative. So 12y minus 4y is going to give us 8y, and 17 minus 9, of course, that's going to give us 8. So if we divide both sides by 8, we're going to get y is equal to 1. All right, so that is how we get to that point right there. Carisi, I hope if you're watching this video you are understanding. If not, of course, hopefully tune into the other 3 examples to get a better layout. All right, so this first example here is just kind of rambling, just kind of going through the steps. All right, let's look at the fourth step. You're now going to substitute this known value. We've just found that x is equal, or sorry, y is equal to 1. We're going to substitute this known value into the third equation that we had created. The third equation that we had created was x is equal to 3 plus 4y. So now what we're going to be doing here is simply just taking the 1 and replacing it with y up here so we can find the value of x. So we're going to sub 1 for y in 3, in equation 3. So let's do that. So we have x is equal to 3 plus 4 times, what's the value of y? 1. So we easily get x is equal to 3 plus 4, and x is equal to 7. So y is equal to 1 and x is equal to 7. All right, so this example was a little bit jumbled or so. So we're going to just get to, of course, an easier way of working out the other example. Let's see if we can flow a little bit smoother using the other example here, okay? All right, so let's get into making sure that it's a little bit smoother. Let's get into this example number 5 here, or the second example of this video. All right, so there are certain times when there are certain times when the question itself doesn't require you to make the variable the subject. Sometimes the question that is given to you already has that variable as the subject. So here, let's apply step number 1. We're going to call this equation 1, and of course this equation 2. So we don't need to create a third equation, because we only created a third equation because we had to transpose this equation here for x. We had to do something to the second equation to get x to be the subject. Here we had to bring the minus 4y over so that we could get the x alone. But in this example over here, we already have y as the subject. So we can skip step 2. All right? Step 2 is not necessary here. So we're going to skip step 2 and jump into the substitution. All right? So we already have y is equal to 11 minus 2x. So what that means for me is that anywhere I see y in this equation up here, I'm going to replace that y with 11 minus 2x. So let's write some notes here. We're going to sub 11 minus 2x for y in equation 2. Equation 2 is pretty much acting as my equation 3. I did not need a third equation, as I said to you before, because we already have the variable as the subject that we want. Okay, let's get into it. So we're going to substitute, and let's do that. So that's the value of y. So we have 2x plus 5 times 11 minus 2y, or 11 minus 2x, pardon me, and that's equal to 37. And then we have an equation all in x. Let's jump and find that value. Okay, so we have 2x here, and we're going to use the distributive law. So we have 5 times 11, 55, and 5 times 2x is 10x, and that's equal to, of course, 37. So what we have here is just to group the terms together. So we have 2x, and we can just bring that minus 10, just move it beside it. We're not transposing, so we won't change the sign. So 2x minus 10x, and that's equal to 37. But we have this 55 over here, which we need to bring onto the other side. So this time we're transposing the 55. It's positive, so it's going to become negative 55. Okay, all right. So hopefully that's working out for you. So 2x minus 10x is negative 8x. And of course, 37 minus 55 is going to give me a negative number. And that's going to give me, let me see here, 37, that's going to give me negative 18, I believe. All right, so we're not getting a really nice number popping out at us here, but it doesn't matter. We are still going to be getting the same result that we really need. Okay. All right, so we have 2x minus 10x, 8x, 37 minus 55. Let's make sure that we're good to go. That's 13 plus 5, 18, negative 18. Okay, so we're going to divide both sides by, of course, easily here, by negative 8. We're going to be getting a fraction for our answer. So x is equal to negative, and we're going to do some reduction here. So we have 2. I can go into this. So 2 into 8, 4. And 2 into 18, 9. So our final answer is negative 9 over 4. Alright, so that's what we get for our x. Alright, so we are going to go ahead now and substitute that value into equation 1. So we're going to now sub negative 9 over 4 for x in equation 2. This should have been equation 1 actually, right here. That's what we did. So let's do it. So we have y is equal to 11 minus 2 times negative 9 over 4. So let's write it better here. So we're going to substitute negative 9 over 4 for x in 2. Okay. So let's do some simplification here. Y is equal to 11. And the negative 2 times negative 9 is going to give us 18. Or we could just simply use the 2 to cancel the 4. So 20 itself 1 times here. And 24 2. So we have negative 1 times negative 9. That's positive 9 over 2. Alright, and then we have a fraction here to simplify. So LCM here is 2. So 1 into 2 goes 2 times, and 2 times 11 is 22. And 22 goes 1. 1 times 9 is 9. So we end up with y is equal to 31 over 2, which of course is 15.5. Alright, so the numbers did not come out as nicely as we'd like them to come out, but the point is I hope that you're getting an understanding. What I'm going to be doing, of course, based on the nature of these questions, I want to definitely go ahead and make a better video with a variety of examples using the substitution method. So you can look out for videos on that with just pure examples. Okay, let's get into the remaining or the final question. Okay, so here we have this last one over here. Okay, here we go. So we have 4x minus 3y is equal to 7, and of course x is equal to 13 minus 3y. So once again, like the previous example, we're going to be skipping step 2 because for this one here it is quite straightforward. I need some space, so let's just move this over here a little bit. All right, good. Okay, all right, good. So we want to realize we get to realize here that this is like similar to the first example. So now we don't need to create a third equation, because what we do have here is that x is already the subject, it's already alone. So we can just clearly do step 1, name our equation, and then of course we're going to just skip step 2 and jump into step 3. So we're going to sub 13 minus 3y for x in equation 1. So anywhere we see x in equation 1, we're going to replace that x with 13 minus 3y. So what we have here is just simply 4. It says x, and x is this expression here. So 4 times 13 minus 3y, close bracket, and we're going to have minus 3y, and that's equal to 7. Okay. Okay, good. So we're going to use the distributive law here. 4 times 13, and that's going to give us easily to be 52. And 4 times minus 3, that's going to give us, well, 4 times minus 3y, that's going to give us negative 12y minus 3y, and that's going to give us, of course, 7 here. Okay, so grouping like terms now, we're going to have the negative 12y, and we're going to have the minus 3y, and that's going to be equal to 7. We have a positive 52 here, so we're going to want to subtract 52 over here. All right, simplifying this part here, we're going to have negative 15y. All right, a lot of persons still may have problems with integers, so a link is in the description below for videos on how to work out integers. So negative 12, this is negative 15y. and when we take away 52 from 7, we're simply going to get negative 45. Alright, now when we divide both sides by negative 15 now, alright, what we're simply going to get is simply that y is equal to 3, positive 3 at that. Okay, that's how we get that part there. Okay, y is equal to 3. 15 into 45 goes 3. So to wrap this up now, remember we don't have a third equation. We're going to say, hey, sub 3 4 y in equation 2. Equation 2 had x as the subject, so therefore we have x to be equal to, of course, easily 13 minus 3 times 3. So 13 minus 9, and so x is equal to 4. Alright, so basically that is how we work questions like that using, of course, the substitution method. Alright guys, so of course that brings us to the end of this tutorial video. I hope these questions are able to help you with the idea of what substitution method is. Do look out for more videos on examples like this and application on question papers, and of course stay tuned for my live videos for CSET CAPE, ADMATH, CAPE, Calculus 1, College Algebra, and so forth like that. Alright, please share, like this video. I love you all. Thank you so much for watching, and I'll see you next time in another video tutorial. Take care. Bye bye.